let me see what I can do, because if I wait for you to go over it, it's probably take too longer than I want to. So f of x is equal to x plus 4 over x. This one is a lot of people have question on. Uh-huh. Okay. Where's Sean Miller at? That kid's always absent.
He gets sick easily.
He does? He's a smart boy, but he's missed too many classes. Okay, so limits as h approach 0. I'm going to plug in x plus h, so it'll be x plus h plus 4 over x plus h, and the minus x plus 4 over x. It's minus 4 over x, I think.
Yeah.
And that's h, right? So what I need to do is I need to make sure those two are combined. Wait, do I need to make sure all the things are combined? Common denominator. I'm trying to think about a simple way to do it, though. Is there any easy way to do this? Well, I can cancel out the x, can I?
Yeah.
So it'll be limits h approach 0. This x can cancel out, so it's going to be h plus 4 over x plus h minus 4 over x all over h. The x and x cancel out. And then what else I can do is I am gonna there's no sure way to do it, huh? Nope. There is no sure way to do it. So it'd be limits h approach 0. I multiply this by x times x plus h over x times x plus h. And I multiply this by x over x. And I multiply this x plus h over x plus h. So then it'll be x times x plus h here. Now that's going to give you what? Well, I'm just going to write this. I'm going to distribute that. So I'm going to look at x plus h, and this one is going to be xh. So it'll be x squared h plus h squared x, right? Plus 4x minus 4x minus 4h. So all over h. So this thing's gonna cancel out. And hopefully I can factor out h. I can. So that's gonna be limits h approach 0. So if I take out h, then I'm gonna give you x squared plus hx minus 4h. No, minus 4. Let me know if I make any mistakes, because I can possibly make a mistake here. X times x plus h. And here is going to be 1 over h. So h cancel out. And h approach 0 is going to give you x squared. H approach 0 is going to be x squared minus 4. Is that okay? And then if I will plug in which one? 4? Negative 4, actually. Right? No, they say it's negative 4, negative 5. Oh, then there's a different textbook then. Okay. So negative 4, you say it's 4 and 5, right? Yeah. So that's going to be plug in f prime of 4. So that's going to be 16 minus 4 over 16. So that's equal to 3/4. So that'll be y minus 5 equal to 3 over 4 times x minus 4. I think that's what I got. It's just a lot of math. A lot of times algebra. Questions? A lot of people don't know how to expand this. You can do it two ways. You can use Pascal triangle, or you can just do x plus h times x plus h times x plus h. And you explain the first two and then expand the next two. Then it's going to be kind of messy, but it's just learning how to deal with messiness. It's very, very important. I have a student, Asim. He's in Cal 3 right now. I don't know if you guys know Asim. Do you guys know Asim? Okay, so Asim is in Cal 3. He says algebra is killing. Like, he need to buy a big board like this in his classroom. He need to go through it. And I remember once in Take Cal 3, it was the most horrendous class. I didn't do homework. It was not a good influence, but I did enough homework for Calc 1 and Calc 2. I like my teacher like make me understand algebra completely. But I remember that final exam was a beast. The final exam is 3 questions, and they keep giving 3 notebook paper. And the 3 notebook paper is filled in from the first line all the way to the last line. It's just math all the way through. Only in the first 2 lines is calculus. The rest of them is algebra. And it just like, after 2 hours, just front and back, 3 notebook papers. And I had to turn it in. And I had to send professor again on differential equation. Same thing. 3 question final exam. A guy from Russian. I can barely understand him. The only thing he does is algebra. So you think this algebra is bad? Wait until you do the algebra. That's gonna kill you.
And just for the part where you cancel out the h, where does that other? Oh, because of the. Okay, never mind. I understand.
The h all the way on the bottom. Okay, so this is the derivative you got, and then go ahead and finish that. Questions? 33, sure. Okay, after 33, if I have to take a derivative, I should get 2x, right? And then, so the other side is 2x minus y plus 1 equal to 0. So it'll be y equal to 2x plus 1. So the 2, so think about this slope is equal to this. So 2x is equal to 2. Does that make sense? Because this is the slope. And if you take a derivative of this, it's going to be 2. Because slope is right in front of it. You don't even have to take a derivative. It's 2. So 2x equal to 2, x is equal to 1. So now what happened is 1. You know at 1. Now I'm going to plug into the equation. So f of x equal to x squared. So I'm going to plug in 1 into here. So f of 1 is equal to 1. So therefore you got and I'm going to plug in f prime of 1. That's equal to 2. So it'll be y minus 1 equal to 2 times x minus 1. And that will be the equation. Yep. I just didn't do that part because that part I should know how to do now. Now, how do I know it's 2x? I do it as shorthand. Now, not all the time you're going to do that. Right now, you're going to do it the long way. Later, you're going to understand there's a much shorter way, a much more efficient way to do something. This way becomes obsolete. But I have to ask you to understand the algebra first before we can do other things. So that's why I give you a lot of training in algebra. It's like actually a crash course of things. You have to deal with conjugate, you have to deal with expansion, you have to deal with other things. I will give you a couple more questions, not all, but I'll give you a couple and see if you can handle more. Because I plug in the 1 into the original function. The original function is f of x equal to x squared. If I plug in 1, that's equal to 1 squared. That's equal to 1. So that means this is 1.
How did you get x minus 1?
X minus 1 is when I said at x equal to 1, they have the same slope. Okay, so let's talk about today. Today, I'm gonna show you a very important triangle. And this triangle is, like I said, I should coach different school teacher. I should teach different teachers out there that in Orange County. And I will show them how things work. This is one of the things I will show them. Says limits as x approach to a from the left of f of x equal to the limit x approach to a from the right of f of x. That means limit exists. And the graph's gonna look like something like this. This limit exists because if you have graph reach the same open circle, that limit exists. The next thing is the continuous. Okay, a continuous says a, f of a must be defined, and the 2, this is a, this is a b, and this says limits x approach to a of f of x is exist, which is the bottom part. C is limit x approach to a of f of x equal to f of a. This is a continuous. You learned that from the last test. Now, what's the last one? The last one is what we do today. It's called differentiable. Differentiable. Okay, differentiable. So differentiable. So for example, like if this were roller coaster, right? If this, okay, so you definitely don't want a roller coaster look like this because that's not even continuous. This example is not continuous. Or so sorry, limit doesn't even exist. Limit does not exist. You don't want a roller coaster look like this. Unless you remember the Phineas and Ferb. They have a roller coaster like that. But anybody ever watch Phineas and Ferb when you were young? Yes. 104 days. 104 days summer vacation, right? The best show ever. You want to sing it, Luke? No, you don't want to hear me sing. So this one is gonna be a, now the limit exists is fun. You still have a hole in the middle. That's still not a good roller coaster. At least the roller coaster has connected, right? So sometimes it's continuous. So for example, this is continuous, but do you want a roller coaster look like this? That's it's probably just as bad way to die as any other way. So you don't want to have that like this. Now, so what do you want a roller coaster to be? You want a roller coaster to be like this, right? It's something smooth completely, right? So the slope of this side, just say, let's take this point. Let's take this point, for example, the slope here from the left to the right is always the same. Now, slope from this point, the slope from here, they are the same. So therefore, it's completely smooth. So what's the last one? The last one says limit x approach to a from the left. It really look like limit exists, but it's instead of f of x, it's f prime of x is equal to limit x approach to a from the positive side of f prime of x. And that's something that is very, very important. And so you need to know that. Now, if its function is differentiable, if the f of x is differentiable, must imply it is continuous. It is continuous. But if f of x is continuous, does not mean f of x is differentiable. Sometimes on AP exam, if you recognize that, you can get a lot of easy points. A lot of easy points. I don't know how many, total about 3. Easy points. Because you cannot build the top part of pyramid without the bottom part. Does that make sense? But you can have bottom part without the top part. So that's why I build it as a pyramid structures. And this concept is including is 2% of AP exam. You only need a 40% to get a 3. And if you understand this, that's 2% without any calculations. Very, very important. So that means everybody in this classroom can pass this AP exam with a 3. Not with a 4 or 5, but with 3, everybody's doable. Done. Now let's talk about when it's not differentiable. Not differentiable. Yeah. Not differentiable means, well, it's not continuous, it's not differentiable, right? And there's a lot of example not continuous. For example, A is a hole, B is a jump, C is a asymptote. So that means not differentiable. Second, sharp turn. Why sharp turn is not? Well, you don't want to have this, right? Or you don't want to have this. That's a sharp turn. All the sharp turn is not differentiable. 3. This one is kind of hard to understand, and a lot of people forget about this one. It's called vertical tangent. Vertical tangent is not differentiable because at vertical tangent, the slope is undefined. I'll give you an example. This one is what roller coaster doesn't really make sense because you are going to get some type of roller coaster like this, right? But the part is not differentiable is this part because that slope is 0. This is not differentiable. How much time I have? When you walk in early, you get me nervous. Good.
Does that make the whole thing not differentiable?
No, it does not make the whole thing not differentiable. Only make that one particular point not differentiable. Simon.
Forgot what's early to say.
Okay, 4. There's one more position not differentiable is at endpoints. Endpoints not differentiable. So 4 situation not differentiable. Endpoints not differentiable is very helpful on the mean value theorem, on the Rolle's value theorem. You're gonna learn that later, but it's very, very helpful. Now we're gonna talk about, is that okay? So today I'm gonna give you a graph, ask you where it's not differentiable. You just have to recognize it. So the next thing is, we already learned this. What is this? F prime of x is equal to limits h approach 0 of f of x plus h minus f of x over h. This is the definition of derivative. And this done and done. We don't have to do this for today. I mean, you're gonna get a couple questions of today's homework like this, but most of the homework question is gonna be what? Definition of alternative derivative. So this one's gonna be f prime of c is equal to limits x approach c of f of x minus f of c over x minus c. You can be, what is this? So yesterday we can find slope at all x value if x is defined. And that means there is no asymptote, there's no nothing. If x is defined, then it's fine. This one is to find slope at x equal to c, which is a single number. I can find the slope at 2. I can find the slope at 4. But it doesn't give you a general form, like I can find slope anywhere. Definition derivative can do that. Definition alternative cannot do that. I'm going to give you an example. How do I find the derivative using alternative derivative? So let's just say if I have f of x equal to 3x squared minus, I don't know, 7x plus 4, something like this. Like, I don't even think this is factorable, but that's okay. I want to find f prime of, pick a number between 1 to 3. 3. Okay, let's pick 3. So we say we're going to pick f prime of 3. Now we can use the definition of derivative, but we can also use definition alternative derivative. I'm going to teach you how to use that today. First, I'm going to say limits as x approached what? 3. Okay, approach 3. And then this is the f of x. I just write down the function. What is f of 3? That's equal to what? 3 squared minus 7 times 3 plus 4. I don't know, what is that? 27 minus what?
21.
Is what? 10 minus 10 over x minus 3. X approach 3, that's going to be 3x squared minus 7x minus 6, I believe. And this end up to be factorable, I believe. 3, 1, 2, 3. Does that work? No. 3, 2. 3, 2. This one is going to give you 9. It's going to give me 2. This one's be negative. So be limits x approach 3 of 3x minus 2 or 3x plus 2 and then x minus 3. And this will cancel out, and I plug in 3, that's going to be 11. I just find the slope at x equal to 3. But in this case, I cannot find the slope at 4, because if I want to find the slope at 4, I have to redo all over again. So you're going to be like, why do we need to learn this? And there is a reason why. Because there is sometimes a function doesn't really work. But this is one of your few homework practice that you have to be able to do. Apply the formula, find it. This formula will look like, in terms of graphing, it's going to look like this. I'm going to say there's a function like this. And this is a point of interest. And this is a point of interest is going to be, we're going to say this is C. And this is f of x. And this coordinate is going to be C comma f of C. And there's another point is going to be x comma f of x. So this is an x. So basically, I want to find slope at this point. But in this case, I start with the blue point. And I want to x approach C. So this one is going to be like this. And this one's going to be like this. Eventually, I'll get to the red line if I approach C. So those are just understanding of graphing perspective and understand that. So every time I explain something, I always explain in algebra and explain graphing. So this is why alternative come in play. Am I going too fast? Okay. Keep on going. All right. So which is situation? Well, this is a situation I think is very, very helpful. It's x to the 1/3. X to the 1/3. And we want to find are they differentiable at 0? Let's just say 0, right? Can I use alternative derivative? Limit x approach what? 0. Good. And this f of x is the x to the 1/3, right? Minus 0 over x minus 0, right? Okay. So limit x approach 0 of x to the 1/3 over x. Can I simplify that? X to the negative 2/3, right? Top minus bottom. What happened if I approach 0 here? It's 1 over 0. It doesn't matter one side or two side. It's 1 over 0. It's undefined. You can do one side limit, but it's still going to go reach infinity. Right? Both sides going to reach infinity, so it's undefined. So therefore, if you look at the graph and you understand why vertical tangent is not differentiable, because this is why the graph is going to be something like this. Do you see the vertical tangent at 0? It's not differentiable. But it's differentiable everywhere else. Not saying this function is not differentiable. It's just not differentiable at 0. So this is why vertical tangent is not differentiable. Because you can actually see it for alternative derivative. If I just take a derivative of this function, it's actually, you're able to take a derivative. It'd be 1/3 x to the negative 2/3. But it does not show that's what's not differentiable here. So another case I'm going to show you, which is this is the case that is interesting. Is this function differentiable? It's a tricky question. No. Remember, I say it's a tricky question. The answer is not no. The function is differentiable at everywhere else except where? Except the sharp turn, which is good job, Min, and also which is 2. Okay, so at 2 here there is a sharp turn. And you're absolutely right. But the thing is only not differentiable in this particular point. This is differentiable here. The slope is 1. The slope is -1. So I can say f prime of 6 is equal to 1 because slope is positive. F prime of 0 is -1 because slope is negative. I can look at the graph. I don't even need to do calculation. I'm going to show you how to do it. But f prime of 2, what will happen? Well, that does not exist because left side does not equal to right side. And I'm going to show you use alternative derivative. So I'm going to say limit x approach 2 from the left. Absolute value x minus 2 minus, if I plug in 2, it's going to be 0 over x minus 2. With that being said, you say, oh, okay, well, that's just 0 over 0. Well, limit x approach 2 from the left. And I say, if to the left, I'm going to use this. And then that will cancel out. That's going to give you -1. That actually show you that you can take a derivative of absolute value function. But from the left, it's going to be -1. From the right, then that's just normal because I don't have to choose the positive side. So x minus 2 over x minus 2. And this cancel out, that's going to be 1. So therefore, limit x approach 2 from the left of f of x does not equal the limit x approach 2 from the right of f of x. Therefore, it's not differentiable at 2. And those are the things that people don't understand. That sometimes when people say, why do we use alternative derivative? It's for the special cases. And this special cases actually contribute that you have does not exist here. How much time I have? Oh, yes, perfect.